Thank you. Okay, we're ready to go. Okay, welcome again to another UX Quiz meetup. I'm Ioannis Feneris, and next to me are the meetup co-organizers, Dimitris Stathis and Dimitris Niavis. Let me say this is a joint event of the communities of Athens and Thessaloniki UX meetups. Keep an eye on those communities on meetup.com for more events in the UX field. And of course, if you haven't done it so far, join the UX Quiz community on LinkedIn. We will give the link in the chat in about a minute. A big thanks to our sponsors who support all those events, Zansin Labs, Anixe, the UX Prodigy, and the From Scratch Design Studio. Thanks once again very much for your support in our community's events. And here is how you can get our today's gifts. Just write a message on LinkedIn saying hi, introducing yourself, saying thanks to Brian, to our speaker, asking anything you want, sharing a moment from today's event with your network. And do this using the hashtags UX and UX Greece from now and for the next 5 hours until the end of the day here in Greece. We are now going to we are going to gather the posts tomorrow and randomly pick the winners and contact them on LinkedIn. Yeah, just let me remind everyone to not keep the questions for yourselves, ask them in the chat. And also you can ask, as we said, Brian directly in the Q&A session after his presentation. That's all for now. Dimitris, I think that you can get it from here and run a proper introduction on our today's guest.
Sure, I will run the shortest, properest introduction. So we have today Brian O'Neill with us, which has been a product designer and consultant for over 25 years, and a musician. And now he's founder and principal at Design for Analytics. Do check out the site. We will post the website link, and host of a fantastic podcast, Experiencing Data, which if you are in product, in design and UX, you should definitely go and check it out. I'm posting the link right now, and the floor is yours, Brian.
All right. Well, welcome everybody. Thank you. I know it's evening. People are getting their drink and food on. So hopefully this is going to be really useful to you today. And I'm going to tell you if it's not right off the top, so you guys can leave if you're like, this is totally boring, because I don't want to waste 90 minutes of your time. I want to bring some really good stuff in for the people who are ready to learn about some of this enterprise data product talk. So let me get the slides going here. All right, we good? Awesome. All right, I got a nod. So let's talk about decision support. I want to talk to you a little bit about what I think user experience and product leaders need to know about enabling successful enterprise analytics and machine learning initiatives. I'm going to use the term data products to kind of collectively talk about these things here. You can consider this to be any type of decision support tool, application that's largely driven by data to provide insights, possibly for automation or augmentation of human work. Because this is very enterprise specific, I'm not really going to be talking so much about consumer uses of machine learning and analytics. There's not a lot for analytics, but in terms of AI and machine learning, this isn't going to be about consumer application design, chatbots, robotics, and some of the other branches of artificial intelligence here. So let's frame this conversation around decision support, because there's way too much analytics and machine learning in the world, and there's not a whole lot of decision enablement going on, which is really the promise of all these technologies. And I think design can help, and that's really what the theme of this talk is about today. Also, if you are here to learn about quantitative research using data science to inform design decisions of any type of product, that is absolutely not what I'm going to be talking about for the next 90 minutes. So you should go home and enjoy your family, go for a walk. This gets conflated a lot, and the reason I have a slide in here is because I've given talks about this before to the UX audience, and as soon as we hear talk about data, a lot of designers are immediately jumping to data-driven design, using data to inform the design process, whether it's research or looking at log data or analytics about your product. That's all great, but that's not what we're going to talk about today. You could think about this as, well, what are the tools we use to do that kind of work? how do we design the tools to do that kind of work? That would be relevant here, because when we're talking about doing quantitative research, we're talking about enabling better decisions. So in that sense, it's related, but this isn't a quant UX research talk today, okay? 8 nuggets of wisdom. Why is it wisdom? Because I'm not sure about all this. I've been in this space in design for about 25 years, and specifically specializing in data products for about the last 6 to 10 years. This is still a new field, particularly machine learning and AI. There's not a lot of design involvement in that. So some of this may be dumb and it may be wrong at the end of the day, but my work is informed by the clients that I work with, and I do specialize in this area, as well as talking at conferences and just interviewing 90 people on my podcast. So that's what it is, but I consider this like an ongoing process of learning, including for me. So just some background there. As you mentioned, I'm actually trained as a percussionist and drummer, so that's my other career. If you guys want to talk about portfolio careers at the end of this talk, we could also jump into that. That's just a little bit about my roots. I got into design back in college when I was majoring in music, when the web was new. This is around like 1996. Actually got my first job interning at an agency because the Flagstaff Symphony Orchestra's website was done by them, their very first website. And I was actually the principal percussionist in that group. And the conductor made an introduction for me, and I began the process of interning and working as a website designer in the mid 90s. So that was kind of the beginning of my career. These days, more relevantly, I help data product leaders use human-centered design to improve the UX and business value of machine learning and analytics. And as you know, I host this podcast as well. So let's jump in. I talked about 8 nuggets of wisdom, right? Here we go. The first one, skate where the puck is going. This is a famous quote, I think from Wayne Gretzky, a hockey player. And the idea here is that the puck is data. And why does this matter? I still hear, just when I have one foot in the UX field, even though most of my audience in my world is hanging out with data scientists and analytics leaders and this kind of crowd, that we're still not getting a seat at the table. Like design is still fighting to get its job done and all of this. Well, part of that is because UX teams need to speak business better. And part of speaking the language of business better is understanding the importance of data, especially the larger the company that you work at. So if you're working in a large enterprise, this becomes more and more relevant. Why? Because all of these companies are generally sitting on large troves of data. A lot of it may be worthless, but they're all trying to do things with it. We call this trying to derive value from this data. And so a lot of that is building out infrastructure, putting stuff in the cloud, building plumbing, doing all this kind of stuff that's supposed to enable future stuff that's actually going to provide value there. And the problem is a lot of this stuff never at the last mile where the humans are in the loop, it fails. And it might be sped out, it might be manifested in an application, it could be an API endpoint, it could be a dashboard. There's tons of these dashboard deserts in large enterprises. No one knows where they came from. They're little one-off projects. No one's using them to make any types of decisions. And it's like, done, on to the next one. It's like McDonald's drive-through. You drive through, you place your order for a dashboard, it spits out the other end. No one knows what happens with it. And these teams are spending tons of money and time trying to find value here. And a lot of it dies in the last mile. They don't understand the customers and the users of these tools. And they don't understand how to kind of close that last mile gap that designers spend all day trying to do, is making sure the interface and the experience works. Because otherwise, you just spent a bunch of money, you didn't provide any value there, you didn't make someone's life better. So know that there's a big problem here. And if you want to drive a seat at the table here, know that data is often going to be a key strategic thing for many organizations, particularly from the executive level. And guess what? A lot of these executives are fucking clueless. They're totally clueless about what AI and machine learning can do. They don't know, they just want it because they hear everyone else is doing it. That gets sent down usually to chief data officer or some head of analytics or CIO. And it's like, let's start building machine learning. And they have some rough ideas of what that is, but they spend all this time and money and very little value comes out the other end. So part of what design can do is make sure that we're actually solving a real problem here. So be aware that data is really important at the executive level to many organizations. They're trying to not always monetize it by selling it, but they're trying to enable better operations, better digital experiences for customers. And they're starting with this data first. Like apparently we have this gold here, and you've probably heard like data's the new oil and all this crap. Yeah, after you refine it, and it's a terrible analogy because data doesn't run out. You don't burn it off and it goes in the atmosphere and it's gone. It doesn't actually go away. So that's not a really good analogy for it. But there is this thinking that we have this raw material and it should be worth something. Dear data scientists, can you help me make it worth something? What data scientists are good at, if the data is in great shape, then they can potentially model it and create algorithms to predict the future, right? But what they're not always good at is figuring out, well, what's actually needed, what's wrong, how are we going to get someone to change their current way of doing things? All this stuff that's like nuts and bolts stuff for product designers and user experience professionals. We spend all day focused on this, and we're nowhere to be seen in a lot of these enterprise organizations. So there is an opportunity here to jump in here and get a seat at the table, but you need to know that that's what a lot of the executives are really thinking about here. We're going to talk about outcomes versus outputs as well. This is a problem both in the data science world as well as the design world. We focus a lot on building the things and not always on the outcome, the future change and improvement the things are supposed to provide. And our job is not to make mock-ups. Our job is to achieve business goals and to make people's lives better, whatever that means. And it means we need to define what is a successful outcome for this project or product or feature or application or tool. This is missing. And so I want design to bring this thinking into the data science and analytics realm, because they really do need help with this kind of stuff. So that's my first rant here, is skate where the puck is going. The second one here, these are not all rants, by the way. This one is not a rant at all. Let's talk about, when we talk about traditional dashboards and analytics tools and things like this, whether you're talking about designing in a BI tool like Tableau or Power BI or whatever, or you're talking about a SaaS application where everything is homegrown, there's a principle here that I think is really helpful here. This is a framework that I've created. Whether you use my framework or not, I'd like the idea of the CED to sink in with you. And the general idea of this is this: nobody wants your analytics. They don't want that stuff. They don't want a dashboard. All that crap is tax. It's another tax to pay. It's another tool I got to go look at. What they want is decision support. They want to make a better decision in the future, and they want to be informed partially by what the data tells them, not necessarily to tell them exactly what to do, but to make it part of the decision making. So what does that mean in relationship to this? It means the tool should try to provide conclusions or opinions. I kind of use the C and this opinions word equally. The goal here is push some useful conclusions to the user first, not evidence. Evidence is things like charts and showing time series charts over times and data tables with spark lines and all this kind of stuff. Yes, sometimes that stuff can be conclusive, but a lot of times it's not. That is the evidence to back up some decision or conclusion. That most users want the tool to do that for them. And so a lot of times when I'm doing an audit of a dashboard or an analytics application, the problem is all I'm looking at is tables and tables and pages and screens and dashboards and charts and charts and charts and charts and charts. And there's nothing that says, hey, look over here, this needs your attention. Here's a recommendation. Here's a conclusion. Here's a relevant comparison that you should know about. It's missing. We're shoveling evidence at people all the time, and we're not using the software to make the conclusions for them. People don't want to spend time doing the work to do that. And one of our enemies is the status quo. How do they do it now? If this tool takes way too long and it's too hard, they're just going to go back to doing it the way they've always done it, whether it's shoot from the hip decision making or random guessing or my experience or whatever all the other ways that we make decisions out there. They're not going to be using the tool. So if you want your tool to get used, and adoption is the enemy, adoption is probably the biggest challenge in the world of analytics here, is these applications and systems and dashboards and tools do not get used because it's too hard to get relevant insights out of them. And they're not designed with intention. A lot of times the visualization piece happens at the end, just like I'm sure some of you have seen this before. It's like, well, the developer did all the wire, they did all the mockups, or they built the prototype and they asked me to come in and paint it at the end. That's called decoration. That's not product design. And I'm not poo-pooing visual design at all. I think visual design is super important. I'm still learning how to get better at that. That is very important, but that is not product design, and that does not help us make decisions. If we're just doing decoration of charts and trying to lay things out nicely, we never actually look at our tools and prototypes with data in them to exercise the design. That's a different thing. So this is really a user experience framework that you guys can use, and I'll give you the link to this at the end of the show. But the data part here, that's really like level 3 in the experience. This is for people that really need to, for example, audit the information. Like, imagine you got a credit score or something like this, and we need to provide proof for why we denied this customer a loan to get a mortgage to buy a home. There may be times where you need to really dig down the weeds and look at all the data that went into the model's projection and all this kind of stuff. That's really like tier 3 of the experience. Tier 1 is, again, that conclusion with just enough evidence for them to say, oh, I understand why the system is telling me this. I can see why this conclusion was made based on this evidence. Sometimes they'll need that evidence, sometimes they won't. Over time, they may begin to trust the tool and they never look at the evidence. That data part, which this is what you see a lot with engineering proofs of concepts, is it's DEC is kind of the order that I'll see coming out of the engineering crowd. And I'm not trying to bash my engineering peeps, but we start with data, and then gradually, like, we throw some design on it. We get some kind of evidence going, and the conclusion's the last thing. Why? Because coming up with the conclusions is the really hard part. That's the part that really requires a lot of thinking about what choices are we going to make, and what is this person, how does this person use this tool in their work? And finding that out at the end is usually terrible for engineering and for data science. They would like to know that stuff earlier. So try to use this as much in the beginning of the process as you can. And so anyhow, we can go more into CD, but we don't need to right now because I have a whole podcast episode on this and an article which I'll send you about how to use this framework. But please think about conclusions and opinions first in these kinds of tools, not last. Okay. Number 3, we have at least 3 parties, or I'm not going to call them personas because that has a specific meaning to designers, but we have at least 3 parties to design for with these tools. So why do I say 3? Well, here, we can kind of tie this to the UX maturity thing. Part of the reason I don't use the word UX too much in my talk, like just the way I talk in my business and to my audience, is because user experience says, yes, I'm just talking to the user, but I don't care or know anything about what the business is doing, what the stakeholders need, or anything like that. All I care is I'm the advocate for the user. And that's great. We do need that. But this is partly why designers and user experience people sometimes fail to get their credibility and to get a seat at the table. Because the business, everybody else is largely focused on not the user. They think that's kind of your job to deal with. They're focused on keeping the lights on in the organization, making sure revenue is coming in so that we can fight the good fight tomorrow. You need to be thinking about the business as well as the users. And with AI systems, we have other personas we have to think about. A notable one here could be affected third parties and classes of people. So these are things like second order consequences. So imagine you're building a tool like, imagine you're an Amazon factory where, I'm making this up, I would not be surprised if this exists, but there's cameras inside one of their shipping warehouses. And these cameras are tracking where all the people that are working in the warehouse are going and trying to find optimizations about maybe how we should lay out the warehouse differently, or where are we wasting a lot of time with people walking from point A to point B. And so you've got facial recognition going on so we can identify who these people are. And I'm totally making this up. The point here is those workers probably were not included in the design process at all. And they may not even know that a whole system is being designed and used around them, even if it's not to punish them. They are just not even they're not at the table whatsoever. So I think designers are particularly good because we have that empathy rooted in our work. We're good at probably helping the business to even know who else should we even be thinking about here that might be affected by this system. And I'll say in the enterprise space, this is probably a little less true when we're talking about internal tools, which is a lot of this kind of work I'm talking about today. It's less for commercial software products for consumers and things that users are paying to use themselves and that kind of thing. But I want you to at least be thinking about it, particularly with AI and ML, because this is, you've heard about biases and all these different kinds of problems that can affect people downstream because the data is biased to begin with, et cetera, et cetera. So designers, I think, are well equipped to be thinking about this. There are even other personas. A great example here is people that do data labeling and rating. So if you've ever seen some of these interfaces for like self-driving cars before, you see this car going through the street and there's like rainbow colored boxes around every object. It's like tree, car, bus, child with angry mom on phone, you know, and it's doing all this vision detection stuff here, right? And you're going through this. Well, guess what? In order to know that this is baby in stroller crossing the street here, somebody had to feed that model a whole bunch of pictures of babies in strollers. Is it a baby? Yes. Is it a stroller? Yes. Is it a baby in a stroller? Yes. Literally somebody or something, most of this stuff is still done with humans as I understand it. This stuff needs to be tagged appropriately. And what does this mean? This means that the people doing the labeling of the data that goes into the machine learning model, they're part of this ecosystem too. So what are the interfaces that they're using? And is there a chance that they're doing some of this stuff wrong? Like where's their subjectivity? Like, is it a shoe or is it a boot? Well, technically it's both, so I'll just call it a shoe. I just hit shoe because the boot button's over there and it's too far, so I just hit shoe. But in reality, the model is supposed to be able to broadly categorize shoe up here, and then shoes have high heels, boots, tennis shoes, whatever. And someone's you know, they're just lazy and they just call it shoe, right? This is probably a relatively harmless example here, but you can imagine if this was more really important information, the labelers are literally putting in biased data into the system. So we need to know what generated this data is a really big part of making sure machine learning models are actually accurate, they're not biased, and that they're actually going to serve the people that they're for, okay? If you want to, the whole ethics thing, I'm just gonna that's a whole chapter of stuff, and there's a robust field of people that work in the AI ethics space, largely researchers. Episode 35 of my show with Kenneth Bowles of Future Ethics. He's got some techniques for doing this as well. He used to be at Twitter Europe, I believe. There's also a book called 97 Things About Ethics and Data Science everyone should know. So if you know the 97 Things UX book, there's also an ethics one for people in data science, but it's an easy read. It's not a technical read. I have one of the excerpts in that book as well, but mine's a satire. So I'll let you go take that for what it is. Number 4, PICA. PICA, what is this? Imagining machine learning user experience improvements. So I created just an acronym here, and I'm going to explain to you what these letters mean as a way to begin to imagine when we talk about our how might we kinds of discussions that we have early on when we're doing design strategy work and we're thinking about products or features or things like this. Imagining cases to use machine learning and AI is not always easy for business sponsors or even for product managers and things like this. And data scientists are also not really trained to be problem finders. They're good at problem solutions, right, in the data space. They know how to model the data. If all the raw ingredients are in place, they can be really good at that kind of stuff. But going out and finding the problem and really being able to explain what that problem is and what the need is, the better future that we want to provide on the other end, that's not something I find is in the DNA of most of the data scientists that I work with. There could be a tendency to at tech companies to want to ML everything. Like ML is now a verb at Google. I had an interesting episode on my show about this. They have their people from the PAIR research term, the People in AI Research, PAIR. And one of their advocates, they go around and they kind of float around some of the product teams there. And partly what they're doing is reminding the engineering and data teams that, you know, our goal is not to machine learning everything. We're not here to ML everything. Sometimes it's not the right solution here. So facilitating sessions, design discovery sessions and things like this it's still relevant to doing machine learning work, but I think understanding what the possibilities are with machine learning is really important so that you can at least have a conversation where we're partially speaking the same same languages here. So what is it? Predict, classify, augment, automate. These verbs are really at the root of what, and again, in the business enterprise context, business intelligence context, these 4 verbs will help you understand where might we make improvements. Okay, so predicting is, you all know what this is here. This is next best action. This is doing forecasting of results. This is forecasting revenues, things like this. This tends to be coupled strongly with this concept of model interpretability or explainability, which I'll get into a little bit later. The second one here, classifying. This is about grouping related items, which could be people, users, things, into clusters that are known and unknown quantities. So a great example of this would be like the way Netflix actually figures out what to recommend to you. They use classifiers for this. So you might fall into the weekend sci-fi adventure warrior beer drinker cluster, and they didn't come up with that. The machine came up with a cluster of people who fit into that, and it might have some really odd types of different people together, but because of the way machine learning works with statistical pattern recognition, it knows that this classification over here, this chunk of people is actually really related, and there's something really unique about them. You can think about classification too as the, when are we using in your designs and your products, where are we asking users to classify stuff that's part of the tooling experience? And the question is there a way we could automate some of that kinds of work? Do we really need a human to do that classification work, or could we use a machine to do that kind of stuff? So you've all heard, like, is it a cat or not? And we talked about the data labeling experience, but that's kind of an example of what I'm talking about there. Augment here. This is probably the most important one that I want you all to think about here. And the idea here is that there's a lot of push in the enterprise to think about AI as an automation solution. It is there to automate as many business processes as possible and remove subjective human decision-making from the loop wherever possible. The reality is that, and this is just recently validated with an MIT Sloan study, is that better revenue, better business value and success with AI comes from solutions where the tooling, the machine learning and AI work that we're doing is augmenting the human decision-making. So it's not replacing it, it's helping that human make a decision. So you could think of this as like, my job is to operate the Volkswagen factory floor. And there's all kinds of things going on as we pump cars out of this factory, right? And there may be reasons that you need to tune this factory, right? Like this part needs to move faster, this part needs to be slower. We have a labor shortage over here. And so, and I'm just totally making this up. This may not exist, but to give you an idea, there might be a manager who looks at a morning report to understand, what do I need to do to get more vehicles to come off the line at the end of the day? My goal is maximum vehicle output coming out of the end of the factory every day. The machine can tell me where there's problems. We have sensor data, IoT data, human feedback. We have all kinds of data that we're collecting about what's going on the factory floor. Some of that could be automated, but a lot of times what we're seeing the better value comes from is the machine says, hey, you should slow down this section, or you need more staffing beginning at 4 o'clock in this area in order to keep velocity the same. It doesn't mean the system's going to go out and call and automate a call like, dear factory worker 789, you need to show up for work and get double time pay this week. It doesn't mean we need to automate all of that. It means a human will make that final decision on what to do, but it's now a data informed decision instead of a fully automated decision here. And the reason this is important too is that these machine learning models are really dumb, okay? And a lot of times there's multiple models that might be in play with an overall prediction, but models don't know anything about the real world. So if there's like let's say there's COVID. COVID's a great example. oh, the factory has all these problems. Like, well, it doesn't know anything about COVID and why people aren't showing up to work anymore. It doesn't know about that unless it's been trained to do that. So this whole idea of general artificial intelligence, if you might have been hearing, that is a long ways off. So these models don't know about the human condition. They don't know what's going on daily. They don't know there's a blizzard outside and it's really hard. The trains aren't running and we can't get to work. They don't know this stuff. And this is why the human decision-making is really important there. And we don't want to jump to automation. As a general rule, we probably don't want to jump to automation unless we're talking about very low risk, very repetitive types of tasks. There's no reason a human needs to be making that decision. You know, a great example, this would be like climate control in the data center. For the most part, turning that over to a machine to make sure we're not overspending on air conditioning when we try to climate control our data center, running an environmental HVAC system, something like that, you probably don't need a human being sitting and monitoring all that. A machine would be fairly good for that. And the ramifications of going wrong there are fairly small, right? So automation has a lot of failures. There's actually a database of these failures. I can tell you about that if you're interested in seeing where AI goes wrong here. But if you remember the 737 MAX aircraft, this is a great example of a fully automated system. Do you remember these planes that were taking off and they were crashing and the pilots were not able to regain control? And that's because there was a fully automated system. It was called the MCAS there. It was not in the documentation for the pilots. They didn't really know about this system. There was no human in the loop involvement possible there. There were no guide rails for this thing. It was a great example of what happens when we jump to automation instead of thinking about augmentation. And so like your autopilot, like on a plane, right? There's times when it makes sense to use autopilot, that the plane can monitor slow changes and make subtle adjustments and things like this, but you don't want to hand autopilot over to a plane in certain types of situations. The pilots are going to have better judgment about that. So we need to be thinking about automation versus augmentation and be really careful when we pull that automation trigger on our projects or products. I'm going to just mention one last thing about this. What can go wrong with these things? Carol Smith has this idea of Black Mirror testing. There's also a thing called abusability testing. These are ways to approach thinking about what could go wrong with these systems. And it's kind of fun because you get to sit around with your team and imagine all the ways you could completely screw something up if the models get off, or the data coming in that the models are trained on gets skewed somehow. What could go wrong? It's kind of fun in the sense that you're thinking about all these negative possible outcomes, but I don't think this is the kind of stuff that data teams typically do. These are things design teams know how to do and should be doing. So jump in on that stuff if you can. Cool, let's keep going. Oh, the I, so Pika. What does I mean? I means ignore. And that's a reminder I put in the acronym that machine learning and AI are not always the solution. Please don't take this hammer to every single job. It's like, I got Avenir, I'm using Avenir on every single project I got. It's the same thinking there, right? Avenir is not the right font for every single, or typeface. It's not the right typeface for every project. So ignore. I'm going to give you a quick example of how you take I'm going to call it a traditional analytics, or sometimes we call this descriptive analytics. So we're not doing any type of prediction or forecasting. We're simply displaying historical information to help people make future decisions. So this is a story about, I'm going to call these the pink slip servers. In the old days, at least in the United States, if you got the pink slip, actually, this is from my chiropractor or my orthopedic appointment this morning, it would look something like this, but it was, you're fired. You would get the pink slip. And so I was working with a software company that provided analytics tooling to people who run data centers. This is before most people were moving everything to the cloud and not managing their own hardware for storage, compute, networking, all this kind of stuff. So these data center administrators, particularly storage and server administrators, their job is basically like keep oxygen flowing through the organization, where oxygen is all the technical infrastructure, servers, emails, all this stuff that we take for granted that just runs all the time. That was their job, to keep that stuff going. And when something goes wrong, they need to know what happened, why did it go wrong, how long has it been going wrong, and what do I do to fix it? And when I came into this, the problem was you see a lot of stuff like this, giant data tables that look like spreadsheets loaded up with what looks like insightful information here, but the signal to noise ratio is quite low here. The problem with this is that this design, and what you're looking at here is a list of virtual machines, which are basically servers, or you can think of them as applications that are in this data center monitored by this team. And their job is to keep this stuff running for all the people that are using these servers, whether they're developers or applications that business people are using, et cetera, et cetera. But this thing did not explain the severity of incidents here. It did not explain when incidents happened. It did not connect an incident to business impact, because it had no idea whether or not like some guy's laptop, some developer's laptop is like the hard drive is full versus like the mail server for the whole company is down. It had no sense of business impact there, and it never gave any actionable advice about why did this happen and what should we do about it, because business downtime is really expensive, especially at the enterprise here. So the redesign here, I just want to show this to you so you guys can kind of visualize the examples. These black, I'm going to call your eye to these black numbers just to kind of walk through this here. But remember, nobody really wants analytics, right? We're back to this decision-making thing. These guys are putting a fire out. They want to know what needs my attention, how severe is it, and how do I put this fire out, which means how do I get the system back up and running, right? So through research and going and talking to these administrators, we found out that what their human workflow was for doing this. And so starting with number one, the first thing we learned is the first question they ask is, when did this happen and how long has it been going on? And this tool had a thing called performance index. Just think of this as like, it's a score for how fast this application is running. And we don't want to see that getting too high. If it's getting too high, it's slowing down. So just think of that's what PI. High PI is bad. Okay, so the first question they would ask is, how long has this been going on? So what did we do here? Through research, we found out with weekends and everything else that basically a 3-day or 72-hour snapshot would give them a really good sense of when did this happen, how recent is it, and is it still going on? The second thing we found out, and I'd say, great, so what do you do then? Let's say it's going on for 3 days. Like, do you take action on it now? He's like, well, the next thing I'm going to do is I want to know if this regularly happens at this time, because I don't memorize all these virtual machines. I don't know what all these things do all the time, but we do have cycles. We have business cycles, backup jobs run at 2 in the morning, and accounting season is at the end of the month, right? So certain applications see higher volume and higher traffic and things like this at certain times. I want to see periodicity. Is this blip abnormal or is it normal? Well, how would you know that? Well, I would look at the chart over, I don't know, a few weeks, and I'm kind of looking for some kind of pattern there. Great. So what if we just showed you like 6 weeks of historical data? Yeah, that would be great. So the next thing they do is they move to 2 here, and they can immediately see that this spike in the last 72 hours is abnormal. If you're looking at Web Trade 1, this first virtual machine here, this is clearly an abnormal spike. Something on Wednesday, something went wrong here, and it took about 24 hours between Wednesday and Thursday to get bad. And it should not be this way. This is not normal for this Web Trade 1. And so the third thing they would say is, okay, now I know this has been going on. This is not normal. This is not the accountants are pumping in their numbers for the end of the month, closing out the books or whatever. Why? What happened? Well, this system was able to crawl and see all the virtual machines in the environment, and it was able to look at CPU, memory, and storage, and surface the conclusion. Remember I talked about conclusions? What it used to do is you would have to dig down into the server. Then you got to choose performance index. Then you got to choose CPU. Then you got to choose memory. Then you got to choose storage, bouncing between screens, trying to put together some type of decision. Should I do something? What should I do? Eyeball analysis, very heavy and taxing on a human being to do that kind of stuff. Instead, we surface the conclusion here, which is right now, the CPU is waiting. This is getting a little technical, but it means the CPU, you've all had the spinning CPU thing before, and the virtual machine is swapping memory. It doesn't really matter what that is, but it basically means your system is running full, like something is going wrong here. That actually would give these users enough to pick up a phone and call the right person and say, hey, you need to go check out the CPU or reboot the machine or whatever. And ultimately, that was the action point is, I want to know who to call about this, or whether it's my problem, because it might be something that I'm supposed to fix. But generally speaking, these people would then get on the phone and call the right administrator to go down and deal with it. You didn't have to go dig through all those screens of data tables and charts. The actionable information was pushed here, and there's no machine learning going on in this at all. There's no forecasting or anything going on with that whatsoever. Okay, so my point here is it is possible to design good traditional analytics, descriptive analytics solutions that don't necessarily use the latest machine learning and AI and still make them useful to customers. Okay, number 5 here. Interpretable machine learning usually beats accurate machine learning. So you guys might have heard of this thing called model accuracy before, but the general idea here is you think about designers, we talk about what really creative work looks like, and we know when we see it, and we can kind of, a lot of times we can agree on what really great creative work looks like. In the data science world, one of the calling cards of your acumen as a data scientist is how accurate your models can be. So this is just using that simple example, like, is it a cat or not? Well, I'm going to feed it 100 pictures of cats, and I want to see how many times your model says it's a cat or not, because my human eye I know what a cat looks like as a human, but I want to see how well your model can predict whether something is a cat. This ability to connect the real world to the model is what we call model interpretability. So it means to a human, they can interpret this stuff. They can interpret what the machine is doing and say, oh yeah, that makes sense. I know why that came up. So an example of low interpretability might be something like if you use Google Maps before and you type, I'm going to go from Budapest, Hungary to Brno and Czechia, and it has you routing through Copenhagen over to Spain, down around Spain, maybe a stop in Portugal, and then back to Czech Republic. And it's going to take 14 days to do that drive. That's an example of a not very interpretable model. Something is wrong and it doesn't click with the human. Why did the machine give me this crazy routing here? That's a problem of what we call interpretability. And the reason I'm saying this is there's something called explainability too, which is not the same thing. Explainability has to do with what points in the model are highly attributed to a particular prediction here. And this is where data scientists love to get lost in the level of accuracy of the model. And what we find out is that in business context, a lot of times you don't need super accurate models for them to be useful in decision making. And I'm going to give you a really great example here. Boring insurance claims. Let's talk about insurance claims. I got in a crash and I got my fender bent in and I want to get my claim. The insurance company wants to process the most important claims first. And this is actually a true story about a data scientist who looked at this problem. And so the business person came in and said, "Dear data science team, is there a way you can sort through all the outstanding claims and tell us which ones to work on first? Because we want to solve the most critical ones first. Whatever critical means, whether it's the most damage to the car or damage to a person, like a reimbursement for medical claims or whatever." They just wanted to know, is there a way to do this? And the problem that happened here is the answer is yes. But the data science team took that to be like, we need to provide a really accurate ranking of all of the outstanding claims and which one should go first in the list, and it needs to be really accurate. And that's not actually what the business wanted. What we found out, what they really wanted there was something better than a coin toss, something better than 50%. 51% would be fine. Why? Because all the claims eventually are going to get serviced. All they're trying to do is accelerate the most needy claims to the front of the line. So even if it's wrong, those customers are still going to have their claims processed. So getting it super accurate, which takes a lot longer, it can require a lot more data, sometimes more infrastructure. It's much slower to do all that stuff. This is where data scientists get lost in the wrong thing. And it's similar to like, your engineers that want to argue about tabs versus spaces, or like which architecture we're going to use, or very low level decisions that have very little bearing on the customer experience. And I'm not saying it means go write sloppy code necessarily, but it means we need to understand what a positive outcome is for the user and for the business. And this is a place where I think design can help. Let's make sure we're not spending too much time on the wrong kinds of quality metrics, because accuracy of the model is not always relevant. We need to think about that human in the loop. What is just enough for them? Okay. So let's talk, I'm going to just change and talk about this explainability versus interpretability thing. So we talked about interpretability. Explainability here this gets into more complex types of algorithms here, and you don't need to know about how to make an algorithm and all this kind of stuff. This gets really technical, and a lot of it's well beyond my understanding as well. But I'm going to give you an example, which is sign language here. So this is an example of a training video where you have a student practicing how to do sign language. And the idea here is, I turn on my webcam and the camera and the application can tell me whether I'm doing the signs correctly, right? And so we have a thing called a convolutional neural network, which is it's a deep learning model here. And there's different kinds of machine learning models. The problem with these deep learning models, they can be very accurate, but we don't have any idea how they really work unless we have an explainability feature put on top of these. And so I'm going to kind of explain why this matters to design in just a second. But what's happening here is when the model, when the software looks at this person practicing their signs here, it's doing a lot of things, such as the first thing it may be doing is saying, is it a person? Yes, no. Okay, on to the next step. Is it a hand? Yes, no. Is it two hands? Yes, no. Is the hand in the right position? Is the hand location in the right place? Is the hand movement in the right place? And then at the end, it might set an answer like ding, 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 you did the sign right, or ding, 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 no, you didn't, error, why, right? This is the idea of model interpretability here. So our UI for this might look like something like your score was 2 out of 3. You got the shape right, you got the movement right, but your location was wrong because this means, I don't know, this means spanakopita here, but if you turn your hand like down here, and then now it means truck with no wheels, right? And just this movement is wrong. What you don't need to surf, and the reason I'm telling you this is sometimes what you'll see with data scientists is they'll show their, I'm going to call it their debug UI as the interface the customers see. And part of what happened when they added the explainability on top of this is they wanted to explain how everything worked. And so the question of, was it a hand, is something that the model needed to be able to do. It needs to know if it's a hand before it can even process whether or not the sign was correct. Does a user need to know whether they held up their hand or not? No, like that's noise in the interface. And so sometimes when you see these interfaces that were built by data scientists, they're going to have all of these parameters and the weightings, the scores that go with each of these parameters on the screen. And as designers, this is where we can come into play and figure out what kinds of explainability really needs to be here for this person to believe the results and to understand just enough about what the system did to provide a great experience. It doesn't mean they need to see everything. They need to see the right kinds of things here. So this is just a rough primer on explainability and interpretability, but this is where it starts to come into play with interfaces here, right? You can imagine, again, like your Google Maps, like it doesn't tell you, even if it shows like traffic overlays on your routing, if you're driving home or something like that, it doesn't tell you everything that went into why it told you to take this route versus that route. That would be overwhelming. And there could be thousands and thousands of little data points or nodes in these algorithms that would be, some of them would not even be interpretable by a human being here. And this is why some machine learning people want to call this statistical pattern recognition and stop calling it machine learning, because the machines aren't really learning anything to begin with. All we're doing is really technical statistical pattern recognition. And the systems can recognize patterns that humans can't even really grok. And so putting that crap on an interface, putting all of it on the screen doesn't make for a better system. But sometimes to a data scientist, they think they're being helpful because they're showing how it works, and therefore it builds trust with the user. But showing everything doesn't make, it can just overwhelm somebody here. So we need to be intentional with our design here. So number 6 here, I'm not going to go too deep on this, but there's a town called Schenectady, New York. I'm actually going to be just 20 miles from there this weekend playing an orchestra gig. And there's this data problem. There's this famous story about the data problem of Schenectady. And in the United States, our addresses, you guys, I don't know if you call it postal code in Greece, and I know we have some other countries here. We call it zip code. Our zip code goes after our state. So I'm in Cambridge, Massachusetts, where Harvard and MIT are, and my zip code is 02140. Guess what the zip code of Schenectady, New York is? 12345. That's the same password on my match luggage if you've seen Spaceballs the movie. Why is this funny? This is an example of what happens when we build models on top of dirty data. And you might be thinking, oh, well, that's not my job. I'm a designer. What does that have to do with me? Well, bad data in means bad predictions out the other end. So designers need to be aware of where did this data come from? Did it come from humans? Did it come from applications? Was it collected in an ethical way? Was it collected accurately? There could be human touch points where designers might need to go back in and say, why the heck are people typing in 12345 in the zip code field? Do we really have 90 million customers in Schenectady, which only has 1 million citizens? Something is wrong here. And so I'm not saying that go look at your postal code data and that's what you need to worry about. What I'm saying is being aware that garbage in means garbage out. And it's really true when we're talking about doing things with machine learning and analytics. And some of this has to do with humans in the loop. Why were they typing that in? Maybe we need to go fix a form on the website to make sure that we're validating zip code against city and state or some other address parameters. Let's stop the problem, correct that data so that the predictions that come out the other end are not biased by this crappy data that went in there. Okay, so it's something that you need to be aware of because bias gets introduced in different kinds of ways, but one of the core ways is bad data. And I'm sure you guys are probably aware of the, Amazon did all of its, was using machine learning to sort through resumes, and it was basically kicking out women. and why? Because all the people, it's the training data that went into that was biased. And some of that had to do with, well, that's the facts about who Amazon has historically hired. So the model is going to optimize on people that they've already hired there before, because that's what the model was trained on. So sometimes that is, the model is actually surfacing insights that are very true, that are not things that we always want to hear about. Other times it's surfacing unintentional things like this, where there's definitely a problem. We don't have 90 million customers in Schenectady, New York. Someone is typing garbage stuff into a form field somewhere. So this systems approach here, and this is what I'm going to talk about in the number 7 here, is really important that designers are bringing this kind of thing in, because this is what leads to problems downstream here. And it's really hard to change these things later, because large investments and money and technology and time and talent have gone into these things. So be aware of this, understand that bias is an important thing, and where is the data coming from? Have that empathy for our users is something that we bring to the table, and we can ask good questions as designers. And some of this gets into my general thinking here, which is there's a bias with data teams to be thinking about data first. It's like, what data do we have, and now what can we do with it? And designers are really good at the human part, which is, what is the problem? What is the need? How am I going to make someone's life better part? And starting with that beats starting with data every single time. But as just a general rule, it's generally going to lead to better, more consistent value for the business as well as for customers. But it does mean we also need to have a systems thinking approach here. We can't just think about, and I think it was Jonas had asked me about this at the beginning, about decorating a dashboard in the last mile and putting it on Dribbble and saying, I'm a dashboard designer. Well, have you ever actually seen that dashboard with real data in it before and exercised all the edge cases to see how the charts scale properly and the decisions that people are able to make with it? We need to be thinking about the systems, the human systems that go into this, as well as have enough of the technical understanding. We don't need to know how to build the models any more than you need to know how to write all the React code for the front end or whatever backend code that you're using. But I do think, on the whole debate about do designers need to code, no, you need to know how code works though. And if you don't know how to have a conversation about an API with the developer, my general sense is you're probably not going to be as successful designing in the software realm, because you don't know your tool sets. And you need to know just enough about that tool set to have an informed perspective. And I think that's really true here too. You need to have some level of knowledge here and think about systems here, and not just about user interface components that we're going to spit out here. There's more here, but I know I'm at my hour here, and I wanted to only talk for an hour so we can jump to QA. So the last one here is, this is kind of my tagline. Nobody wants analytics or machine learning or AI, and they might ask for it. They don't want this. There is a promise that is implied by these technologies here. And this is like, if some of you have been around long enough, you know, like a web 2.0, like we need social media. What does that mean? Like we need social media. Like what are we trying to do exactly? And it doesn't mean social media is wrong. It means we're leading with a tactic. We're leading with a possible solution, implementation solution. Downstream from that is some type of value. What is the value that this person wants? What is the better life we're going to give to this user? What is the business outcome that you're trying to get to? This constantly is a problem. And I see it all the time, because when clients come to me, usually it's like, we want to redesign our dashboard. And I'm like, no, you don't. You don't want to redesign your dashboard. You think your dashboard has a problem, and that problem is manifesting itself in some way, like customers don't want to buy our product, or the demos take too long, or we're getting complaints about it and we don't want those complaints because it's bad for our brand. You come to me though and say, I want my dashboard redesigned. We need to dig behind that. You should not be taking out Sketch or Figma and swinging at it because someone said we need the dashboard redesigned. That is not the beginning of the adventure. The adventure starts somewhere else. There's a reason that problem was expressed to you that way. And you need to question the stakeholders and the users and get to the actual problem. Sometimes this is called the presenting problem, which is I need a better dashboard or whatever. You hear like, I need a new logo. No, you don't. You don't need a new logo. You want some promise of what a new logo is going to give to you or to your business, whether that's personal confidence that you look great, or whether or not if I want more leads, or I need to look different than my competitor who looks too similar to me and they're crushing us. There's some value behind that, and we need to dig for that. So just remember, nobody wants this crap. And I talk to my team, my data teams all the time about this. They don't want that. So don't just shovel an answer at them. Don't just give them another dashboard or a model and say, here's what you asked for. That's the drive-through McDonald's version. Order up at the window. What would you like? Sure. Would you like fries with that dashboard? Done. Wrong format. And this is how I hate to say it, this is how a lot of data teams are currently working. And part of it is because the people working this space say, it's not my problem if they don't know how to use it or they don't know what they want. I gave them what they asked for. That is a disaster waiting to happen. And I think designers, we know that what's required to go and actually surface those problems and those needs through the process of doing research. It's natural for us, and I think we can bring that skill to the table. So just to kind of wrap up, I'm not going to read all these back to you here. These are kind of these 8 ideas of my wisdom. And again, I already changed some of this stuff. I gave this talk at UXPA Boston conference back in September. I've already modified some of this. I had wrong stuff in here, so I don't know all this stuff. This is really new space. So just know it's an evolving space here. But I think it's going to be really relevant more and more, particularly again in the enterprise space. And if our designers are aware of this, you're going to succeed. And I am seeing the hiring more of large enterprise businesses where UX and product teams are specifically hiring designers with machine learning and AI specialization. All the FANG companies have design teams that have specialization in these areas here. In fact, Michelle Carney just was on my pod yesterday. I released my interview with her. She runs the MLUX group. She works on TensorFlow, which is an application for data scientists that Google runs. And she's actually a former data scientist and neuroscientist turned UX researcher. So she's great. She runs a regular meetup. So check her stuff out. And those are just, by the way, if you want to take a quick screenshot of this, these are kind of my more UX-y oriented interviews. My show, I tend to interview executives and chief data officers and heads of technical product and data science. Not so much people coming from the UX world, but I'm doing more of that. So these are all people that have some connection to either ethics, artificial intelligence, or UX. So I'd recommend any of those interviews. In particular, if you want to see that AI incident database from Sean McGregor, that was a fun episode. That's a great place if you're wondering, like, where does design fit in? go read all the incidents. And these are basically news articles. And you've heard, we talked about the Amazon resume thing. You've heard about like credit scoring for people trying to get mortgages and how it's biased based on bank data. This is a whole database of these articles about where machine learning went wrong. You've heard about the problem with facial recognition, treating Black people and people of color differently. It's loaded with those. And so sometimes seeing what went wrong is a good way to say, oh, now as a designer, I know what I need to be thinking about here. It's good to see examples of that. So check that stuff out. And in terms of my stuff, if you want to follow my writing and work here, if you hit that URL, you can hop on my mailing list. I'll send you a link to my CED framework. It's just my website /CED. If you don't want to go on the list, that's the link to the CED framework. And I do publish that podcast every 2 weeks and write and speak and all that kind of stuff. That's about it. If you need personalized help, you can check out my site, designforanalytics.com/services. And that talks about kind of how I work with teams. And that's basically it. Just want to thank you guys for listening. I've been talking for about 1 hour straight. So I did hit my mark here. We want to have questions. So hit me with your questions. My email address is there. I'm not super active on Twitter, but you can definitely get me there. I'm more active on LinkedIn because that's where all the data nerds hang out. And that's my tribe I'm trying to help primarily these days. Questions?
Thank you.
I'm
Awesome,
going to
Brian.
Stop sharing.
What an interesting topic. Thank you so much for all of this information. I'm sure there are a lot of issues to discuss. So let's start our Q&A part. We have about 20 to 25 minutes. We're going to give you the questions that we're asking in the chat. And all of you, please raise your hand to ask Brian directly. This is why we're here today. Grab the opportunity, ask Brian. There are no out of context questions. If you have any question mark in your head, now's the time to turn it into discussions and knowledge. So please raise your hands. I'm going to give priority to you. If we don't have any raised hands, let's go back to our questions backlog. Dimitris, do you want to start, or Dimitris, do you have anything to start with?
Dimitra has asked a fantastic question, and it's about some examples. If you can share some examples when using abusability testing and black mirroring testing as well, and what are some of the challenges of doing that?
Sure. So do you guys know Black Mirror? It's actually a Netflix. It's a TV show, and so if you just go and check out some of the episodes there, it's basically about like you know, when technology goes wrong, and they show there every episode is different. It's not like a drama series or something like that, but it explores what goes wrong. Like there's an episode about how people can like use their eyes to record video all the time, and then they can go back and replay incidents and how that doesn't necessarily make people's lives better, being able to record everything that's happened and replay all this stuff all the time. And so the idea of the Black Mirror testing is really to envision what could go wrong when we're building a model. So if you take like the Google Maps, for example, here, what kinds of things could go wrong if the model is not generating the right types of recommendations for routing? And so you could come up with a variety of things like, well, pollution. We've got all the cars going over one bridge now because the model is favoring speed, but it doesn't care about, you know, traffic density, and all the traffic routes through the poorest part of the community. So we have all these trucks and all this commercial, you know, trucking and stuff going through one part of the city. So those citizens have to listen to the noise pollution. They have to take in the smoke pollution that's there. And so that's an example of when we do Black Mirror testing, we're trying to figure out and envision the negative sides of things, right? And the abusability testing is things like, you know, one thing Carol Smith talks about when I interviewed her on my show, and she actually works on defense. So she's very interesting. She works on weapons and defense at Carnegie Mellon University with the DoD, primarily in when we're talking about autonomous weapons and things like this, which are not fully autonomous. There's still humans in the loop. But there's the military has they have a whole set of guidelines about ethics when we're using machines to make life and death decisions. And so that's really that's the area of UX research that she is in. So I would recommend listening to her episode about abusability testing there. But part of this can be like, and you can imagine what could go wrong in a military context here. with these kinds of tools. But another example can be, and this is, you'll see this in the people in AI research guidelines from Google about designing for machine learning, is this idea that customers are often going to play around with apps. You've probably seen this with chatbots before, where people type in funny stuff and they start to play around with the experience there, and understanding what some of the negative things that could come from that is important. And part of that's abusing the system to understand what it needs to do. And so why does this matter? Well, an example, this could be a system where it requires some training data in order to make future predictions on something. And so it needs access to your device, and you first have to open an account, you have to launch the app, and it needs access to your device, and it needs to collect some data. And you start putzing around with it or using it in a way that it wasn't intended to be. And the system doesn't know that you're playing around with it, and it doesn't provide any way for you to undo this playing around. And now the system starts to suggest things to you. And so I'm having a bad example, giving you a very specific example of this. But the idea here is that designers need to be thinking about the fact that customers may want to play around with this experience here, and that they could be putting bad things into the system, that we need to provide some type of way for them to handle that, or provide feedback, or start over, or whatever it may be. We need to be aware that data that's going to be used for predictive purposes later can affect their future there. And so they need to be made aware of what's going on with that kind of stuff. So the idea here is not, is it easy to use? It's actually, can we break the system? Like how could we attack the system from a user's kind of perspective, playing around with it, doing things that wasn't intended for? What's another, I'm trying to think of another example here. I'm hoping that helps. I had to chew on that one a little bit more. My brain's got fried from talking, but definitely check out the episode with Carol Smith. She would be a great one to listen to on my show if you want to go a little bit deeper on that.
Okay, awesome. I have a question, and I have to throw it right now. I have a big why. We have thousands of products, we have thousands of UX designers or designers of all domains who have a lot of years of experience in the industry. It's new, but it's not new.
Yeah.
Why are we still need to talk on the basic, which is designed for adoption, not just for decoration? Yeah, I have a big why in my head. So what do you think about that?
Yeah, I mean, this is a true whether or not we're talking about data products or not. My general position on this is pretty simple. The issue here is that, and this isn't just true for designers, this is true for other domains. Data scientists love to talk about data and models and all this kind of technical stuff, right? And the business is often just like, I have no idea, like this person has a lot of letters after their name, like PhD and whatever, and I have no idea what a statistical regression is, or a p-value, or I don't, what are they telling me? Like, get this person out of the room. Like, can someone tell me what this person just said? In the same way, designers love to talk about design shit. And the problem is we're not doing a good job talking about how does our work help the stakeholders who pay for this work? How do we help your business? How do we translate what we do into a way that they can understand in their language? And so this is why when I have running my consulting business, I don't just start redesigning a dashboard or an application. There is a trigger. Why did this person call me right now? Something changed. What changed? Well, our funders aren't going to fund us because they think this thing looks like crap, or our sales have dropped off significantly, and we're the demos aren't closing, and sales is complaining that the demos are, I can't sell this product. It's too freaking complicated, and everyone says HubSpot is doing a better job. It's too hard. So they come to you and say, we need the onboarding experience changed. Why? What they really want there, and they don't always come in knowing this, they have a sense of it, but they try to tell you in words that they think are helpful to you, which is, I need a new dashboard. I need a new onboarding experience. What is the outcome you want from that dashboard? That's the thing that we need to isolate. And designers have not spoken about this. We want to talk about process and how we didn't follow this thing, and we didn't do research this time, and all this kind of stuff. And it's like you versus the builders, and the builders win every time because they're shipping stuff. And you're talking about process. And the business stakeholder behind this is just like, how much money am I spending? And is my job safe? Because if I don't get this thing out the door, at least if I get it out the door, I can say, hey, we shipped something and my job feels safe. So connect your work to the people who are paying for it. Speak their language. And this means, I hate to say it, it means if you want to be senior and you want to move up the ranks, you're going to need to learn to speak the language of business and connect what design does to the business. And it can be through the lens of the customer, but you need to help explain how that work connects. And I don't mean talking about typeface choices. If they really want to go into that and you have a type nerd who's the CEO, fine, you can have a sidebar about why you chose the typefaces you did. That for the most part, that is completely irrelevant. Don't talk about that stuff because it makes you look like, yes, you're really good at, just stay over there and do that stuff, that little magic art stuff you guys do. You know, I don't know what that's all about. But when you start talking about things like engagement and how like experience, people are just talking about this on social media because it's so kick-ass. It's so much better than everything else. We are getting a brand boost simply because we changed the way you get quotes for insurance. And it sounds stupid, but people love the talking gecko at the end that tells me how I save money on my car insurance. And it's like, what is this doing for the brand? What is the business change that we've seen? We've seen sales go up this much, or whatever those things are. This is what builds trust. And over time, you're probably not going to have to justify every one of these decisions because what your stakeholders are hearing is, Ionis gets it, or Dimitris gets it. Like, they know what we're trying to do, and they ask me good questions about what I want to get out of this product. They didn't just start swinging at the dashboard or the application. They asked me, how would we know if we did a good job? Like, if we fast forward 4 months out, how would you know if this dashboard was well designed? Like, what would we test? Like, if we just call this an experiment, what would we test? What would the metrics be to know it's better? Guess what? They don't know. Bam, workshop time. Now you've got a seat at the table. Ask the good questions you know how to ask. Get to success criteria. Put numbers on those if you can. Even if they're the wrong numbers, get started with a baseline and get them to say, do you think this is the right way to test this? Is this the right way to know if we did a good job? They're going to tell you if it's the right way. And just the fact you're asking this question is what builds the credibility there, because they don't know how you're going to do it. Like, this stuff is magic. It's art. We know it's not art, but to them, to a lot of people, it's this wiggly gray space where like there's not really a process, and like we put sticky notes on the wall, and it's like totally unstructured. And this is the crappy creative space that we all live in, and we find just normal, and it is not normal for others. So we need to try to meet them where they're at and talk in their language. That's my explanation of why we're still having this conversation. In the data space, it's different because we think of, I think these teams traditionally have not thought that you have a BI developer. That's what they call it, is a BI, a business intelligence developer. This is a tool user. This is like saying we need a Photoshopper at the end. We need a sketcher at the end. They call it a BI developer. I'm not picking on BI developers. A lot of them have done a lot of training to get good at data visualization, which is one piece of this design process, is the data viz part. And some of them are quite good at that. But we also have to make sure we're not just here to visualize the data, right? We're here to enable an outcome. And if the data is the wrong data set, it doesn't matter if you visualized it properly, because you didn't enable a decision, which is the promise of most of the analytics and machine learning. The promise is better decision-making, not properly visualized data. And that's where sometimes only thinking about data viz goes wrong. And so we were talking about this before everyone got here about like looking on Dribbble, and you see quote dashboard designers, and we see the donut charts. Why? Because all the other designers are using donut charts. Why? Because we don't know what else to think about except the cosmetic layer. And the reality is when I see that stuff, I'm like, have you actually prototyped this? Have you ever seen this with real data in it? What does it look like when it's abnormal? What does it look like the first month before there's any data? There's no sales data. What happens in these empty states here? How does the customer feel when they have no sales on this dashboard and it's 18 blank bricks on the page? Like, it baffles me there. And some of that is just, we don't have the experience yet. And these are people that maybe are really skilled at the visual part and they haven't learned the product part, and we need to upskill there. And that's a training thing and all of that. We all have our different talents that we come in the door with. But if you want to get a seat at the table here, you need to learn to speak the language of whoever your stakeholders are that are paying for this stuff. And they will pay for value. And you need to help them understand what value is. And that's part of what my coach calls the why conversation. We all know about the power of asking why here and doing laddering here to get at what's really behind this stuff. And it rarely comes out in a brief. It's never going to be in the screening call or the brief. It's not going to be there. It never is. It's always hidden behind something, and you'll know when you hit it. And you focus on those outcomes, they're going to stop asking you about, can you make it pop? Can you make the logo bigger? Can you make it blue? Why doesn't it look more the way Google does it? And you go back to the outcome and say, isn't our goal here to get higher throughput on the onboarding, get people into the experience earlier, and get them to share this thing with their mom? Is that the metric still for this project? Okay, then let's focus on that and stop talking about the typeface. Our job is to figure out the right fonts and the flow here. We're relentlessly focused on this success criteria that you said was get them through the onboarding, get them to the dashboard, and get them to share it with their mom. We are relentlessly focused on that outcome. And here's where we're at with it. Has that changed? No, that hasn't changed. Great. We'll see you next week, whatever. Get back to the outcome. Stop talking about the outputs.
Awesome. Thanks a lot.
Got me on my soapbox there. Sorry.
Do we have another? We have some questions? Yeah, Dimitri, go.
Question from John Pagonis that wants to nerd out more about neural nets and UX. So, John, would you like to unmute and ask yourself the question?
Sure. Yeah. Good afternoon. Yeah, I want to ask, where does the massive trend towards deeper neural nets leaves us in terms of interpretability and therefore making UX better for the users that consume the information?
Sure. I don't have a ton of opinion on this, except to say that I think there's no such thing as just like this technology should not be used. There's a reason we have some of these kinds of technologies, and they enable us to do some really amazing things that would be hard to do with other types of implementations, right? I think it gets back to the right tool for the right job, but also setting expectations with users about what is this tool really doing and what can it do for me here. So you think about like GPT-3, one of these things that can, you can give it a topic and it's going to write a whole article for you on something. Well, guess what? That article is derivative based on the training data that went into it. So if you're going to build a tool around this or some promise around this, what is the user going to think that this tool is doing? Because that shit can look like magic to some people, and they may think that this machine is doing something that it's not. And I actually just saw a recent article in the Times that was, I think, talking about GPT-3, and there was some, I think Ben Schneiderman's list, he just wrote a great book on HCAI is kind of his token word for this, human-centered AI, and trying to bring design into the AI world. So I haven't had a chance to read it, but check his stuff out, University of Maryland. And a reader had written into his list to kind of talk about even the way the media had presented this. It was kind of like it was magic. And it sets expectations wrong about how this technology can be used. So I think part of this is even when we think about onboarding users into some of these solutions that use machine learning, it's helping the users know what the boundaries are. And so sometimes you see this in chatbot where it's kind of making fun of conversational interfaces, because most of them, at least in my experience, have been terrible. The best ones just get me to a human as fast as possible. It's like, get me out of there. Thank you for getting me to a human. Like that's my judgment of a good chatbot. Now, I think technology takes time to get right, and that's not necessarily the fault of the designers. A lot of this gets into the data, and there's a lot that goes into doing that kind of stuff right. But the part of the onboarding process of those things, and I think a good example is, hi, my name is whatever, I'm your Fidelity assistant. I can help you with placing a trade, changing, updating your credentials, and blah, blah, blah. And immediately it set a frame like for what it knows about it, what it doesn't. And so this is an example of something where you're doing a good job of explaining the boundaries of what the technology is so that people aren't misinterpreting what it's for and what it can do. I was actually just yesterday looking at a very interesting writing application. So I do some advising for MIT. MIT has like an incubation program for students called Sandbox. And so the student is working, he's from Turkey, And his company is working on this writing assistant where you've got your kind of like Google Docs, you just your Microsoft Word, you've got your document that you're writing, and on the right side, it's actually pulling in research, and it's pulling in conclusions based on research that has to do with the topics in the article that you're in. And you can actually fact check these nuggets of information here. And while the interface needs a fair amount of work, in my opinion, I think they're doing a good job just by, for example, having something that says fact check. It says this machine can be wrong. These predictions could actually be wrong, because we're not just crawling the web for related information. It's actually trying to generate a conclusion based on the topics that it went out and looked at. So it actually does some very interesting things where it goes and says, like, here's the citation. It's a McKinsey PDF report that said this. And you can see how the machine came up with a conclusion based on these facts there, but it allows the user to go and understand where this stuff is coming from so that they can make the final decision. Do I really want to put this into this article that has my name next to it? So that's very different than just like self-writing an article, and some content marketer, yes, I can publish 1,000 articles now on digital transformation, and I don't care what it says in there. And because the machine just does it for me, all I have to do is spell check and make sure it doesn't sound like a robot, and I'm done. Because the promise was not made clear. The expectation wasn't set clear. And I think even with the promise there's going to be people that try to abuse this stuff anyways, and they use it poorly. And we're not going to, I mean, people write whatever they want today anyways. We're not necessarily making that worse than the problem. But the model accuracy issue with the deep networks, the reason they're used a lot is because they scale and they're much more accurate. And so when you look at, like, why did the car make the decision that it did, these self-driving cars, there's all kinds of models that go into these systems, and some of them need to be explainable for audit trail purposes, like when there's a crash. Some of that stuff does not need to be explained, and so we can use some of these what we call black box models there, because we don't necessarily need to explain those. The issue gets into when we're using a model that probably does need to be explainable explainable to a user, and it's not, because we went with the more accurate model, but nobody knows how it works. We really don't know what's going on under the covers. If you really want to get into this space, I did interview Cynthia Rudin, who just won the $1 million Squirrel Award for AI. Her whole focus has been on model interpretability and explainability. And she's actually, I think it was John that asked this question. I would check out her stuff. Her position is basically that we don't need to be using these models a lot of the time. And this whole idea that black box models are, quote, better is not necessarily true. And all of her work has been focused on this space. So you might want to check her out.
Yeah.
I hope that helps.
Which episode was that?
Cynthia, Cynthia, I don't know the number, but that's her name. So if you type that, look on my site, or just type in my name and her name, you'll probably come right up.
Okay.
I don't have a browser open right now.
Super.
We have time for one last question, or I don't know, many.
Good questions.
Another one. So how do we make truly human-centered AI using AI in the products, when sometimes the inner workings of how the model works are a black box, even to the people that are actually building these?
Sure. Well, I think we just kind of talked about this, right? So I think there's times when it matters. Again, we need to understand how it works, and there's times when we don't, because the stakes are low. So recommendation systems, this is a classic one, right? Like, what song should I listen to on Spotify next? What's the damage if the song recommendation is wrong? It's pretty freaking low. Like, we skip or whatever, right? So I think the question isn't so much like, how do we show how it works when it's a black box? That's not the right question. The question is, do we need to show how it works? And why do we need to show how it works? Generally, that's because I don't trust it, or I have a question about it, or I'm making a really important decision on this, and I want to know where that came from because it surprised me. So I think we need to go back to, again, what is this person? What is their challenge? What is the promise? What is the outcome that we're trying to help this person achieve? And then ask the question, well, how much of the inner workings of the model really needs to be exposed to them or not? One of the examples, like in that tool that it was called Balance Point, where I showed you how we redesigned that tool without using machine learning. One of the things there, we call this root cause analysis. So this is that tool that was trying to troubleshoot which server is wrong, why is it wrong, what's going on with it now. This is called RCA, or root cause analysis. And so one of the parts of the analysis that can be really helpful to a user is, what did the system not check that I might think that it checked? So for example, that system looks at all the data topology. It looks at the way data moves to the system. It does not know anything about the physical hardware. Is it plugged in? Yes or no? The system has no way to know if it's plugged in or not. Someone literally tripped the power cord, or some device is not attached properly and used to be attached. It doesn't know anything about the physical world. So in the analysis, when this tool would trigger a root cause analysis and say, hey, we're seeing abnormally high CPU usage on this server here. Here's what the system checked. Balance Point looked at X, Y, Z, A, B, C. Balance Point does not know anything about A, B, C, D. Why? Because in our research, we know that that last set of A, B, C, Ds, that's stuff that these data center administrators would normally do as part of their work being a data administrator. What they don't know is the tool's boundaries. What does the tool know about the world? Oh, this is helpful. I need to go check that stuff. So your prediction could be right, or your analysis could be right, or it could be wrong because you don't know anything about the physical situation that's going on in the data center. Cabling issues, no backup path, no redundancy. It doesn't know anything about that kind of stuff. Knowing that it doesn't know is really helpful information to have in the interface. It builds trust, and it helps me know, especially when we get an analysis that's wrong, it helps me know that it's why it's wrong. Oh, I get it. Yeah, the machine's dumb. It doesn't know that it's not plugged in. That makes sense. That's why there's no traffic on the mail server. That cannot be possible with 150,000 employees, that there's no one checking email right now. Something is wrong. Oh, the tool doesn't know anything about cabling, and it's probably not plugged in. It's good to know that. So that, I think we need to come back to, what is the user trying to do? What are the questions they're going to have? This also gets into exercising predictions. So outlier predictions, and this is why we don't need to build these solutions to test for this stuff. What do people do when they get predictions that are way off? This is not what I expected. This is way lower than I think. So an example of this could be like a pricing tool. I'm a sales guy. I sell widgets, and the quote form that I give to a prospective customer, the system's going to tell me what to price it at. And you're telling me to sell carrots to all the grocery stores in Poland at $15 a pound. And the system is supposed to dynamically price this stuff. I can't get out of my head, how can we charge them $15 a pound when they don't use dollars, they use zloty in Poland. But that's a different point. The point is, it's 15 times higher than we charged them last month. I'm not going to write that down. Why? Because I have no idea how the system came up with that number. That's an example where we need to exercise that. And as designers, we'd probably say, great, how would you validate whether or not that number makes sense? Like, you're saying it's not. What would you need to do to be convinced it's right? Well, I would want to see, like, where are all the carrots going? And is there a carrot shortage everywhere and everyone else's prices are also high? Like, and they start rattling off all the stuff that they would go check in the normal world that they came from, right? And this tells you, hey, as a designer, what if we provided all that analysis, that evidence to them at the right time? Would that get them to trust putting 15 pounds for carrots or whatever on the quote sheet? Maybe it will, because we're showing our work. We're showing the evidence that went behind this. And it also says, this application knows how you think. It knows how you like to price stuff. Here's us showing our work in the tool for you. Ultimately, you get to write down whatever price you want for carrots. But if you get a sales commission on it, right, there's an incentive here now, which is, my goal is to sell carrots at the most expensive price possible. As a sales guy, that's the outcome I want for me. So they want to push that price as high as possible, but not too high that they lose the sale. This is a great example of where data and decision support comes in. Help me understand why you think I'd love to put 15 down, but I'm scared to death to put 15 down. It's 10 times higher than I put down last month. And you're telling me they're going to buy it for $15? Show the work. Show me how you came up with that. Design, we can test this stuff. We can help the data scientists learn here's the proof and the evidence that we're going to have to provide in the interface. Make sure your models can show this stuff. They need to show the work. They need to show the steps that went into this. Otherwise, they're never going to type in these prices. And if they don't type in the prices, the entire business gets nothing out of this work except R&D. That's all we got out of it, was we did some R&D and we provided no business value, because all the salespeople are still typing in quotes based on what they did last week. The safe quote that they know will get sold, because they don't really care if the business makes money. They just care about their commission. You know, that's my rant on that.
That's awesome. Brian, do you have like a couple of more minutes for another question? We have Constantino.
Sure.
Thank you very much.
Hold on. Hold on 1 second. Let me just double check I'm not blowing somebody off here on my calendar. I think I do. Yeah, I got a few more.
Okay, thank you very much for your time. Constantino,
Sure.
I saw your hand. Where are you? Wherever are you, open your, turn on your microphone and shoot your question.
Hey, can you hear me?
Yeah, loud and clear.
Yeah.
Okay. First of all, thank you so much, Brian, for your ideas and your experience. I was wondering about the presenting problem that you mentioned. I was not quite familiar with the term, so it stuck to my head, and I was wondering, how can we make sure, that on one hand, we actually find out and that we can make sure that we work on the problem that the business faces, rather than what the stakeholder presents us. Like you mentioned, we want a new dashboard. How do we make sure we found out the actual reason without the stakeholder feeling like they got hustled, or that we try to avoid working on what they wanted us to do?
Got it. Yeah, so I would look at the discovery and the why questioning and all of this as your job is to probe there and to get them to surface what's important to them. It's not so much that you're trying to avoid doing the work or anything like that. It's we together are trying to define what a successful outcome is, because we, the makers, don't want to make the wrong stuff, and we don't want to find out at the end that all this time we spent was on the wrong thing, and that you're evaluating us on some criteria that we had no idea about. And I'm sure a lot of you have probably been in projects where what we call in the US, the swoop and poop. Poop. Some executive comes in at the last minute and has not been involved with anything, knows nothing about the users, and they come in and they shit on the project at the end, the swoop and poop, because they were not involved. And that's because they were not properly managed as a client or a customer. That is a failure of leadership to not manage the process. And so getting upstream and really uncovering what the desired outcomes are there and reframing the conversation about them. What did they want? What did they need? Why do they need that right now? And by laddering up, you're usually going to get past the surface level stuff and find out what the real reason is. And one of my favorite questions is like, why now? Why are you calling us now? So if you're in an agency and you get a lead coming in, something changed. What changed? Did you just get money and you've been waiting all year to do this? Did the CEO yell at you and said, get this shit together or you're fired? Like, I'm using like crazy language here and stuff, but something changed. What was the prompt for that? They may not tell you that because they think, to Konstantinos, it's not relevant. And the reality is, it's like, it's really relevant because you're doing this work for the company, but you're also doing this work for that person. That individual human being has a stake in it. And if they're deciding whether to work with you or somebody else, they've got a reputation. They're putting their money down and saying, I'm going to work with this firm or this designer instead of that one. They're putting their trust in you. And so the more you can help get to surface what's behind the presenting problem there, and it's about letting them surface it. By you asking the right questions, they're going to spit it out. And it's really on us to ask the questions. It's not to answer it. Sometimes we can guide that and say, are you saying that you're getting verbal complaints that this is hard to use? And sometimes we have to see that, and then they'll correct you. No, we're not getting complaints about it. It's more, so-and-so, or this really important investor told me it could be better. In fact, here's the answer. I just had a client, this startup, they're just waiting to close some funding, and they're in the insurance claims area, and they're using machine learning to figure out which claims should we process. We don't want to be sending out money to people that's fraudulent claims. We don't want to send money to people that didn't actually have a valid insurance claim, right? And he's like, I need the dashboard redesign. Well, when he said dashboard and he showed me his thing, he's talking about the entire product. So his language for this is dashboard. He has an entire application that's required to do this kinds of work, right? And so if I just listen to what he said and start swinging at the dashboard, I have no idea what's right. And furthermore, when I started asking him questions, part of the reason he's doing this is that he thinks user experience is really important, doesn't really know why, but he's heard about it enough that I know that's going to matter here because my enemy is the status quo, the way they do it all the time now. I'm fighting that. I got to get them to use this new tool, which is better for them. It's like, here's your vegetables, eat them. Yes, but it's really hard to get people to eat them. So he knows enough that design can probably help get people to eat their vegetables, but he doesn't know how. And I kept asking why he cares about this so much. And he said, because one of the investors I talked to said, you know, it looks pretty good, but I think this could be a lot better. So what's the success metric? Part of the success metric for that project is this important investor or this role model or whoever this person was, and I don't know their name yet, them feeling like this is on the right track is part of this person's criteria for success. So I might say to him, if we do a project together, are you saying that, so do we need to get this person involved? Like, does it make sense to talk to them? Like, is their opinion going to matter about this? Because if it is, I'm going to want to talk to them and understand, how are you measuring the success of this? Is it cosmetic? Is it usability? Is it utility? Like, that person has an opinion and it matters to this person. And simply by me caring enough to ask, and it shows that, like, oh, your reputation, like you care about this person. So if we did all this work and this person doesn't say, yeah, that looks a lot better, are you saying that you would not be happy? Yes, Brian, I would not be happy because that's the reason I'm here. Yeah, you didn't tell me that on the intake form. You said you wanted your dashboard redesigned. But now we're talking about the opinion of some person that you care about as having a lot of impact on this because you trust what they think. And that might be part of the success criteria for the project. So what am I doing as a designer? I'm trying to figure out, okay, I got to go talk to John. What does John think? Why does John care about this, the way this application looks? And guess what? We'll probably find out some weird stuff, which has nothing to do with the fonts and the colors. It's like, John's like, this is too complicated. You should see the competition. There's 4 other apps doing this way better. They're way simpler to use. This thing is, no one's going to buy this. Oh, really? Now, guess what? We're past the presenting problem again. And my client's now really happy because I'm understanding his stakeholder, what they need. And I'm asking a question that shows I really care about you getting what you want out of this. And you said, my arm hurts, give me surgery. No surgeon cuts your arm open and just gives you surgery because you said, I would like surgery on my arm. No, they diagnose the problem first, right? I want to be able to play soccer. That's my goal. I don't want to have surgery on my leg. I want to play soccer for the rest of my life. Can you help me play soccer? I mean, like, really, the job of a surgeon is to be a healer. Surgery is a tactic. Healing is the outcome that we want, right? It's the health outcome we want. Hopefully we don't have to do surgery. That is only one tool in the toolbox, and hopefully they don't have to use it. So really, calling yourself a surgeon is actually a horrible name. It's like, you're a healer, and one of your key tools is surgery.
So ask the right people the right question, get the answer.
Yes.
Go one step
Yes.
further. Great,
and people will pay you handsomely for that.
That's so true. So just let me find my screen. This is my screen, and let me share again. Dun, 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 dun. Great. Okay, so Brian, thanks again for being here with us,
Sure.
for your extra time, for answering all of our questions. If you have more questions, please ask them on LinkedIn. I'm sure Brian will respond in just a few minutes. I'm sure about that. Speaking of that, you can both ask your questions and discuss with Brian and win some of our books while posting your questions on LinkedIn. Use the hashtags UX and UX Greece for the next about 3 hours, or just say hi, thank Brian, share some of your takeaways to your network. Again, a special thanks to our sponsors, Zansi Labs, Anixe, the UX Prodigy, and the From Scratch Design Studio. And also, don't forget to join, first of all, don't forget to follow Brian, because there are some great information, great ideas, great knowledge to gain from his boss. And also, don't forget to join the UX Greece community on LinkedIn and stay tuned for upcoming events. And I think that that's all for today. Thank you everyone for being here, and see you again very, very soon. I'm going to stop the recording now, and we can chat a little if you have some time.
Cool. I got a couple of minutes. I got another meeting coming up, but thank you for having me. It was a pleasure. I hope that was helpful. A lot of talking, hopefully some actionable insights.
Thank you very much.